All right, here we go with Unit 2.09. We're going to be finding the roots of polynomials, and what we're going to do today is use just common sense and some things we already know about regular old integers and real numbers to apply them to polynomials. And at first it may seem kind of ridiculous and crazy, but once we really dig deep into it, we're going to see that it's exactly the same thing that we've been doing all our lives. So here we go. All right, so the first thing we want to talk about are factors. Let's just take the number 10. Can you tell me a factor of 10? I bet you can. Maybe the most popular one might be 2. 2 is a factor of 10. Why is 2 a factor of 10? Well, it's a factor of 10 because if I divide 10 by 2, I'm going to get some number, an integer out. It goes in evenly. Okay? Well, now let me ask you this. Could you find another factor of 10 using the factor you already have? I bet you could. Take 10, divide it by the factor we have currently, 2, and you're going to get 5. And 5 is also a factor of 10. Why? Because if I divide 10 by 5, it goes in evenly. In fact, it goes in exactly 2 times. And so, you know 2 factors of 10. You started with 1, and you were able to find another. Also, let's think about what that means. 10 is equal to 2 times 5, right? When I found all the factors, or these 2 factors, and I found one of them, so I found 5 using 2, that meant that 5 times 2 was going to equal 10, right? That's what division says. If I want to take 10 and divide it by 2, I'm asking how many times does 2 go into 10? And it goes in 5 times, so 2 times 5 will equal 10. And this idea applies for any number, right? You could take some number like 188. You know 2 is a factor because it's an even number, and you could find another factor of 188. All right, we want to keep this in mind because we already are aware of some other types of factors that we've been working with pretty commonly. I'll give you one example. Here's a linear factor, and these are the building blocks of our polynomials we've been working with, and interestingly enough, they work just the same way as regular integer factors. All right, so we're going to take a look at this problem. Given a polynomial function f of x, x squared minus 4x plus 3, you are told that f of x has a root at x equals negative 1. Does f of x have another root, and if so, find it. All right, so let's just take stock of what we've got. We have this polynomial, and we are told one of the roots, and the question is, does it have another root? Well, what degree is this polynomial? It's a second degree polynomial. So if it's a second degree polynomial, I'll just write the progression here. It's a second degree polynomial. What does that mean? Well, the number of the degree that it has to have, if it's second degree, how many factors must it have? It should have 2 factors. And each factor will tell you a root. So if it has 2 factors, it will have 2 roots. All right, and this is that key theorem that we've learned previously, right? The degree of the polynomial, it will have exactly that many roots. And so, yes, it will have one more root. So now the job that we have is, how can we find another root? Well, let's think about what this root tells us. If we know that there is a root at x equals 1, what else does that tell us? And hopefully you thought about the number of factors, right? If I know a root, that root has to correspond exactly to a factor. So what does that mean? Well, f of x is equal to, of course, x squared minus 4x plus 3. And that's not in factored form, right? Here I've expanded it all out. But if I were to write it in factored form, well, how many factors, first off, how many factors will it have? It will have 2 factors. And what does one of those factors have to be? Well, it's got to be x minus 1. Why is that? Well, because we know the root is at 1, so we know that when we factor it up, one of our factors is going to go to 0 when we plug in 1. So this has to be a factor. Well, let's think back. Remember, if you had the number 10 and you knew one of the factors, say 2, how would you find the other factor? In other words, how will we find this missing factor? And why do we want to find that missing factor in the first place? Well, this missing factor, remember, we're looking for the other root. If I knew this other factor, would we know the other root? Certainly. So the goal for us now to find the other root, the key move that we're going to make is we're going to look for the missing factor. Okay, so now comes the big moment. How are we going to find that other factor? Let's think about our example that we had previously. Remember, we had 10, and we know 10 had a factor of 2, right? What was the number that we could multiply 2 by to get 10, right? What was that number? What was the other factor? How did we find that other factor? Well, to find the other factor, we simply divided by 2. And dividing by 2 will give us that the missing factor we're looking for has got to be 5. So taking this same concept, what could we do with this expression here so that we can find our missing factor? And I don't want you to worry about the fact that this might seem strange. Use common sense. How can we isolate this factor and find out what it is? Just like we did down here, we're going to want to divide by the factor we already know, which was 2 in our example, and dividing by the factor we already know will allow us to find the missing factor. Because think about what that does then. X minus 1 divided by x minus 1, well, those are the same thing. They cancel out. And so all I'm left with is going to be my missing factor. What is going to tell me my missing factor? Well, it's going to be what happens when I take x squared minus 4x plus 3 and divide it all by x minus 1. And so now we're at a point where the question that you should be asking yourself is, what on earth do I do with that? And the good thing is, it works just the same way as 10 divided by 2 did. Okay? So taking that, we're going to now go ahead and talk about what exactly will happen when we do this division piece. Okay? So let's think about what this statement says. Just like 10 over 2 says take 10 and divide it by 2, this statement here says take x squared minus 4x plus 3 and divide it by x minus 1. What does that mean? Well, think back to our original situation here, where we said this polynomial is equal to x minus 1 times this missing factor. So what we're looking for is the factor that we can multiply x minus 1 by to get our original polynomial back. In other words, what we're looking for here is that polynomial, this polynomial here, this missing factor, that when we multiply by x minus 1, this polynomial that when we multiply by x minus 1 is going to give us back our original polynomial. And so in thinking about the fact that our answer will have to be multiplied by x minus 1 to equal x squared minus 4x plus 3, we can think about how this whole process will work. What do I have to multiply x minus 1 by to get this whole polynomial? Let's start with the first term. What will I have to multiply? And I'll just put these here so we can remember this is our factor. What am I going to have to do to get x squared? What can I multiply x by to get x squared? Well, it's a pretty simple answer. I just multiply it by x. Because if I were to multiply these two factors, x times x is going to give me x squared. That's exactly what I want. Now, remember, when I multiply these two factors together, x will be multiplied by x, but the distributive property tells me it will also be multiplied by -1. So think about just what we did with 10 divided by 2, right? We wanted to do the same here. So when I'm multiplying x by x minus 1, I'm going to get x squared minus 1x. And that's what I will get after multiplying this first term of my factor by x minus 1. And so now I just want to know, what will I have to multiply this last piece? What does that have to be so that when I multiply by x minus 1, I get whatever I need that's remaining? Well, how will I find what's remaining from my polynomial that I need? Simply by subtracting away what I've already gotten from x times x minus 1. So to do that, I'm going to subtract away the piece I already have, and I'm going to subtract, so this negative sign will distribute in. So it's going to become a minus x squared and a plus 1x, because I'm subtracting this whole piece, so I've got to distribute my negative sign in. These will cancel, which is a good thing because I don't want to have to deal with an x squared anymore. That was the whole reason I did x times x in the first place. And negative 4x plus 1x will be negative 3x. And I'll drop down the 3 because I have nothing to subtract from that, plus 3. So let's take stock of where we're at this point. We've multiplied x by x minus 1. We know that that'll give us an x squared and a negative 1x. And then we've said, okay, let's take that away from our big polynomial. What am I going to have left over that I need from my multiplication of my missing term here and x minus 1? Because the distributive property tells me I'll multiply x by x minus 1, and then I'll multiply this term by x minus 1. And when I add those two pieces together, I need to get x squared minus 4x plus 3. X times x minus 1 gets me x squared minus 1x. So now all I need left is the negative 3x plus 3, because if I were to combine these, notice I'd have x squared minus 1x minus 3x, which would give me minus 4x plus 3. So I'd have everything I could possibly need. So what will I have to multiply x by to get negative 3x? Just negative 3. And now when I multiply negative 3 by x minus 1, I'm going to get negative 3x, exactly what I wanted. I got negative 3x plus 3, because the negative times a negative. And these are going to cancel out. When I subtract the two, I get exactly what I need. So they'll cancel out. This becomes a plus, and this becomes a minus, and so they'll cancel out, and I'm left with nothing. I don't have a remainder, which makes sense because this is a factor, right? And so when I am factoring, when I have a factor and I divide my bigger polynomial by my factor, I should end up with no remainder. Just like because 2 is a factor of 10, when I divided them, I ended up with no remainder. So the answer to my question is simply x minus 3. That's the missing factor that I've been looking for. Okay? And we can check our work. x times x